Welcome back to Bugs, Buzz, and Beyond. Today, we're diving into a tiny but fascinating question. Do ants have a GPS? You might have seen ants marching in a perfectly straight line to a food source or returning to their nest after what seems like an impossible journey. How do they do it? Is there a tiny ant version of Google Maps guiding them? Or is it something even more incredible? And stick around until the end. We'll have a fun trivia section with questions about these amazing little navigators. Our topic for today is, do ants have a GPS? How do they always find food? First, let's tackle the question head-on. Do ants have a GPS? Not in the way we think of it, of course. They don't have satellites or smartphones, but they do have extraordinary natural navigation skills. Ants rely on a combination of methods to find their way. Scientists call this path integration. Essentially, ants keep track of the distance they've traveled and the direction they've moved from their nest. They use visual cues, the position of the sun, and even the patterns of polarized light in the sky to calculate the most efficient route back home. Some ants, like the desert-dwelling Cataglyphis species, are masters at navigating harsh landscapes where landmarks are scarce. Researchers have observed these ants trekking hundreds of meters across hot, barren sand, seemingly without any reference points, and returning directly to their nests. It's like having an internal compass and odometer built into their tiny bodies. But path integration isn't the whole story. Ants also use chemicals called pheromones to communicate with their colony. When a forager ant finds food, it releases a trail pheromone as it returns to the nest. Other ants detect this trail and follow it to the food source. The more ants that travel the same path, the stronger the pheromone trail becomes. This allows colonies to quickly and efficiently exploit food resources. Interestingly, pheromone trails aren't permanent. They evaporate over time, which prevents ants from wasting energy following outdated paths. In this way, ant colonies have a dynamic navigation system that constantly updates itself based on the availability of food. Some species even use different types of pheromones to signal danger or mark their territory. So ants aren't just following a trail blindly. They're reading chemical messages left by their fellow workers. All of this adds up to make ants incredibly efficient foragers. Colonies are always on the lookout for food, and the coordinated effort of multiple ants allows them to cover vast areas. While a single ant may seem small and insignificant, together they operate like a well-oiled machine, exploring, marking trails, and communicating to ensure the colony thrives. And here's a fun fact. Some ants even engage in a behavior called tandem running, where one ant literally leads another to a food source while the follower learns the route. This social learning ensures that the knowledge of food locations spreads quickly through the colony. In other words, ants don't just rely on instinct, they actually teach each other. So, while ants don't have a GPS like we do, their combination of path integration, pheromone trails, landmark recognition, and social learning makes them one of nature's best navigators. They are a testament to how evolution can produce complex behaviors in the tiniest of creatures. Next time you see ants marching in a line or disappearing into the ground with a crumb of food, remember, they are navigating a complex world with tools that we're only beginning to understand. All right, let's see how much you learned. Here are 3 trivia questions. Ready? Let's get started. Question 1. How do ants keep track of the distance they've traveled from their nest? A. They use the position of the moon. B. They count their steps and use path integration. C. They ask other ants for directions. D. They follow random trails. Correct answer. B. They count their steps and use path integration. Ants use a method called path integration, which combines their sense of direction and the distance they've walked. Think of it as a natural odometer plus a compass. Even without visible landmarks, this allows them to navigate directly back to their nest. Question 2. What role do pheromones play in ant navigation? A. They help ants fly. B. They mark food sources and guide other ants. C. They increase the ant speed. D. They repel predators. Correct answer. B. They mark food sources and guide other ants. Pheromones are chemical signals ants leave behind. When a forager finds food, it releases a trail pheromone back to the nest. Other ants detect this trail and follow it. The trail strengthens as more ants follow it, creating an efficient system to locate food quickly. Question 3. What is tandem running in ants? A. Ants racing each other. B. One ant leading another to a food source while teaching the route. C. 2 ants carrying a large piece of food together. D. Ants moving in circles. Correct answer. B. One ant leading another to a food source while teaching the route. Tandem running is a form of social learning. The leading ant guides a follower to a food source, and the follower learns the path. This ensures that valuable information about food locations spreads throughout the colony efficiently. Next time you see a line of ants, you'll know that it's not random. It's precision, teamwork, and a little bit of chemical magic in action. If you enjoy this video, please check out our other bingeable channels. Thank you for watching. If you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you an acknowledgement for your contribution.